This is Module 5 of Chapter 12, where we'll look at two payoff functions for a couple of option positions. Here we have the profit diagram before maturity for a long call position. And in this graph, you can see that this is a net payoff position. This is the investor's position, who originally paid $6.29 for this call option, and is then going to calculate the profit by either the expiry value of the option minus the cost, or if sold earlier, the sale value of the option minus the original cost. And that's what these profit diagrams represent. So for example, the 1 day after the option is purchased, we have this top graph. This is 1 day after. And we can see that if the stock price, which originally was 40, stays at 40 for that 1 day, the investor would have a net profit of roughly zero. And this means that if the investor bought the option for $6.29, 1 day later sold it, the investor would pretty much get $6.29 back if the option price did not move, and therefore the net profit would be roughly zero. In general, the investor would lose at least a little bit of theta, a couple of pennies. But you can see that, on the other hand, if the stock price over the course of 1 day moved up to $45, the investor would make a profit because the call option would be more valuable 1 day later when it was sold. And correspondingly, if we look at a $35 price, the investor would have lost roughly a few dollars, $3, simply because when the option was sold a day later, it was less valuable than the original $6.29 that was paid for it. And we can see successively each one of these curves. The next one is 6 months later, the next one down is 9 months later, and finally it's the profit diagram at expiration, where we see the familiar payoff profile of a call option. And we can see that as time passes, the profit loss profile for the investor gets closer and closer, as expected, to the payoff profile at expiry. And we can see that at expiry, of course, if the option value is less than $40, the investor loses 100% of the original cost of the call, whereas if the stock price exceeds the original $40 value, the $40 value, the investor will make some money back. And even, as we can see here, once stock prices get above $46.29, the investor actually starts earning a net profit. The next profit diagram that we'll investigate is a so-called calendar spread. And you may recall a calendar spread is where we go long a long-dated option and short a short-dated option, typically with the same strike price on the same stock. So in this example, we're going long a 1-year call and short a 3-month call. And the goal of the investor will be to settle this position on the expiry of the short call. That's the typical strategy. So the goal is to put on this position at time 0 and at time 3 months to liquidate the remaining 9-month option, which would be left from the original 1 year, pay off the short position, which might be in the money, and settle the portfolio at that time. So again, we have a holding period now. So we now have our time being measured from the time the investor puts on the position. This investment position costs the investor, because the cost of the 1-year option, of course, will exceed the cost of the 3-month short position. So the investor needs to invest $3.50 for this calendar spread. And just as with the prior diagram, if we look at the 1-day diagram, which is here, this 1-day diagram says if the investor waits 1 day, and liquidates the position, what's the profit and loss? And what we can see is if the stock price stays around 40, the investor makes a little bit of a profit. What is that? Well, that little bit of a profit, if the stock price doesn't move, is basically the theta. The negative theta of the short position is greater than the negative theta of the long position. In other words, the diminishment in value of the short position is faster than the diminishment over time of the long position. So every day that goes by, the investor makes a little bit of money on theta, and if the stock price doesn't move, we can see that over the course of the 45 days, then 91 days, the investor ultimately makes roughly $1.78. And what that reflects is just the accumulated value of theta over these 91 days, and that being that at time 3 months, the short position would expire worthless. The long position could then be sold for a value, and the investor would net a profit of $1.78 versus the original $3.50 price. And this is also true for a range. As you can see, that as the stock price moves outside of the original strike, the profit associated with the theta starts getting diminished. And interestingly, it gets diminished whether stock prices go up significantly or down significantly from the original strike. And let's understand why that's true. The first thing is note that this position is a long delta. The delta of the 1-year option exceeds the delta of the 3-month option. So this investor is net long delta. And just knowing that, what one would expect is that the investor loses money when stock prices drop and makes money when stock prices go up. So it's a bit of a surprise that we, on the one hand, while we do see the expected drop in profit when stock prices drop associated with that long delta position, we don't see profits when stock prices go up. So what is going on here is, again, we do have the drift of, we have a profit flow coming from theta. That's always true. And let's see what happens in turn if, first of all, stock prices drop. Well, we're long a delta, and so as prices drop, not surprisingly, the value of both of our options diminish. And when we get to expiry, if prices drop all the way to, say, $20, it looks as though we've lost the entire $3.50. This means that, of course, the 3-month option would expire worthless, and at a $20 stock price, the remaining 9-month option would effectively have no value either and be sold for pennies. If, on the other hand, at expiry, at 3 months' time, the stock price was at 30, the investor would recoup about 50 cents of the original investment. In other words, again, the short position would expire worthless. The long position would be perhaps worth 50 cents. So when stock prices drop, it's pretty clear why the investor is losing all of the original investment. Let's now look at the case where stock prices go up. Initially, since the investor is long delta, we just expect profits. We should be getting, intuitively, theta profits plus delta profits. But here's where the term actually plays against the investor, and that is because the short option is going to expire at 3 months' time in the money, the delta position of that short option is increasing to 1 relatively quickly. So you have that, even though initially the long option has a greater delta than the short option, as stock prices go up, the delta of that short option has to increase very fast because it's going to converge to 1. It's going to be in the money in 3 months, and therefore the delta will have to be 1. So what is actually happening is that the delta, this is a gamma effect really, is that the delta of the short position increases so quickly that it ultimately dominates the delta of the long position, and so ultimately the investor ends up being net negative delta, even though the investor started as positive delta. And so ultimately we have losses, while smaller losses than we had earlier. And what we see is that, for example, if the stock price ended at $60, the investor would end up losing about $1, which means that the investor would have recovered on liquidation at time 3 months, would have recovered, say, $2.50 from the positions, which is to say that the long option would have been sold for roughly $2.50 more than the expiry value of the short option. And that's how the investor ends up losing only $1 rather than the original $3.50. And of course, the reason that the long option is sold for $2.50 more than the short is expiring at is because of the time value remaining in the long option.